permutations. In this case, we are selecting objects from a group. So you might be wondering, what does that mean? So let's say you are shopping for hats. There are 20 different types of hats, and you have enough money to buy 3 of them. You are selecting 3 hats from a group of 20. Alternatively, maybe you don't care about hats. Maybe you really love video games. So let's say you go over to GameStop. Their stocks are soaring right now. So you go over to GameStop and you want to buy 2 games. You have, let's say you're looking at only the used Nintendo Switch games, and there are 18 different games to choose from. You can buy 2 of them. How many different combinations, how many different ways could you make that decision? That is where permutations and combinations come in, when we have multiple options and we are picking more than one of them. So suppose we have a group of n objects and we want to pick r of them. If each object we pick is its own decision, so there's r total decisions, are these decisions independent or dependent? Pause the video, make a prediction, hit play. And now that you've paused and hit play and you've rejoined us, let's actually discuss what this might be. So I don't know why that changed color. That's new. In any case, confusing, unexpected things out of the way. So are they independent or dependent? And why might that be the case? So the first decision, let's in fact just get rid of that. So the first decision, picking the first object from the group, changes the exact outcomes, options, for the following decisions. However, the number of options remaining does not change. So in a sense, these are independent decisions, but they also depend on each other because we are picking them one after the other. So to really drive this home, the order in which we make dependent decisions may or may not matter for the end result. So the outcome after all decisions have been made. For example, let's go back to hats and video games. So let's say with hats, I buy, that's a really ugly looking hat. That's a little bit better. There's a reason I went to grad school for math and not art. That one looks like a dead duck, goodness. So let's say we have 3 hats. I could move these hats around in any order I want, and they're still the same 3 hats. So the order that I pick these hats doesn't matter. However, if I'm looking at video games, let's say there's like Kingdom Hearts 1 and Kingdom Hearts 2. Both games which have never released on the Nintendo console, so I have never played them. But I've heard they're good. In this case, if we're just looking at these 2 games, the order would matter, because if we play the first one second, we're likely not going to really be following the story. And so we can make up situations where the order might matter based on the result. Or if I'm picking games specifically to play first, then the order would matter. If I specifically wanted to look at hats to wear to breakfast, lunch, and dinner, then the order would matter as well. So whether or not order matters is going to dictate whether we have a permutation or a combination. So when order matters, we have a permutation. So a selection of R objects from a group of N objects when order matters is a permutation. You may not be familiar with the factorial symbol. So if we look at a number such as n factorial, what it means is n times n minus 1 times n minus 2 all the way to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. 3 factorial, 3 times 2 times 1. 1 factorial is just 1, and 0 factorial is also 1. Going into why this is the case, we won't go into, but partly it's to make sure that we don't ever divide by 0. So 0 factorial is just 1. So the formula for a permutation, a selection of R objects from a group of N objects when order matters is a permutation. N, PR, equals N factorial divided by N minus R factorial. And what I like to remind myself is that N is the total. R is how many we select out of this group. So some examples. Anna, Beth, and Carlos are in a contest that has a first place prize, a second place prize, and a second place prize. Explain why order matters. So order matters because first and second place are different. So first and second place are different. So the order in which we pick them is also going to matter. So when we compute our permutations and combinations, we are going to more often not rely on our calculators. We often have an NPR function on our calculators. However, since this is the first time we're doing it, and even though I would love to be able to show you on every calculator, I don't have one of every calculator to show you. But the general idea would be if we have 3 people, that's our N, and we are picking 2 of them for first and second place, we have the permutation 3p2, and this is equal to, let's check that formula, n factorial over n minus r factorial. So 3 factorial over 3 minus 2 factorial. So we have 3 factorial over 1 factorial. So that's 3, 2, 1 divided by 1. The 1's cancel out, and we're left with 3 times 2 is equal to 6. And that is our example for calculating the number of permutations. Again, if you've got it on your calculator, use it. It is a tool. It's there for you. Go for it. Combinations. So selecting objects from a group when order doesn't matter. A selection of R objects from a group of N objects when order doesn't matter is a combination. Now you might be looking at this and thinking, what the, this is too much. Okay, so number 1, a deep breath. Inhale, exhale. Number 2, let's look at each of these individually. First, we still have the total and the numbers selected. In this case, however, we're using a C for combination instead of a P for permutation. This notation you will sometimes see in textbooks. As much as I love it, because you can make a fun Pokemon pun out of it, because it's pronounced N choose R. The reality is, as long as you recognize it, it's just another way of saying combination. And at least in this class, we are always going to use NCR over N choose R, just because consistency is easier when we're learning. The third part here says we take the number of permutations and we divide it by the number of ways that we can order groups of size R, which is R factorial. And finally, this gives us our final formula, n factorial over r factorial times n minus r factorial. And if you know this is NPR. So it might look like a lot at first glance, but once we unpack it, it's a lot simpler. So Annabeth and Carlos are semifinalists in a contest, and only 2 of them can move on to the finals. Explain why order doesn't matter. So in this case, no matter who goes on to the semifinals, or excuse me, the finals, they are in the same position. There's no distinction between which 2 people end up as finalists. So all finalists are equal. There's no difference whether you are the first finalist or the second finalist, you still end up in the final round. So that's why order doesn't matter. Now we want to compute this. So as before, remember that n is 3, r is 2, and our formula for n choose r, so 3 choose 2, is n factorial divided by r factorial times n minus r is 2 factorial. So we have 3 times 2 times 1. Then we have 2 times 1. Remember that 3 minus 1, or excuse me, 3 minus 2 is 1, and 1 factorial is 1. So now our 2's cancel out, our 1's obviously cancel out, and we're left with 3. And so this is it for our example on combinations. I do want to give a mnemonic. So if the precise order matters, it's a permutation. If we can't care about order, it's a combination. There are certainly other mnemonics, memory devices that can help you remember this. This is one that I find useful for myself. There's also a really good read about easy permutations and combinations. This is from Better Explained, so I cannot take credit for this excerpt, and I will do my best to remember to put this link in the description for this YouTube video when I have it put up, so that full credit can go where full credit is deserved. But what the author suggests is that permutations are for lists when order matters, and combinations are for groups when order doesn't matter. So in our next video, we will be doing some more applications with all of the counting principles, and then that will wrap it up for this lesson.